Hi everybody, I am going through that first part of the Unit 2 notes that I promised I would do. So we are actually going to start on page 2, but I wanted to make sure you knew where we were at. So we did talk briefly about those different formulas that were on the front. As far as the different geometry things, just a few things I wanted to point out. So for geometry, for the rectangle, you're going to have a length and a width, and for area you're going to multiply those together. Perimeter, we have two of each of them, 2 lengths and 2 widths, and these things are all on the Math 40 formula sheet. Now you also see a square here, and a square is a special kind of rectangle, just one that has all sides the same length. So sometimes we will look at these formulas and we'll use S for side, and that the area of a square is S squared, and then the perimeter is 4 times S. But it's exactly the same as using the rectangle area formulas. So I don't recommend memorizing these just for the sake of having these memorized. Know the rectangle ones and you'll be covered for a square. It's just a special rectangle. Flipping over to the next page. One of the things that can be tricky remembering with the triangle area formulas is that there are 3 different places that the base can be. So we've got the area is 1/2 the base times the height. And the base and the height have to be perpendicular. So, in one instance, we have it like that, and this would be in a right triangle. So, this special triangle that has the right angle in it. So we can have a height there, and then this would be the base. In other triangles, the height is not necessarily one of the sides of the triangle. So in this middle version, if I'm going to call this one the base, then the side, I go to from the opposite vertex, and I'm going to sketch in a perpendicular, and that is going to be the height. So it is not one of the sides of the triangle. And that can also happen in this obtuse triangle. Obtuse because it has an angle larger than 90 degrees here. This one, we have to extend the base, and the height is also still not one of the sides of the triangle. But we're going to go to this base, but this is the only length. We only use the actual length of that base side. And then the height will be this perpendicular distance between the vertex and this extension of the base that we're looking at. And also, don't forget with perimeter for this, it's just going to be A plus B plus C. So just add up the 3 sides. So notice that, again, the height is only one of the side lengths if we have a right triangle. Otherwise, the height is most likely going to be outside of the triangle. It is not going to be included in a situation where we are looking at perimeter. With circles always have fancy names for things. So instead of perimeter, circles call it circumference. And that is where we get to know the number pi. So that's approximately 3.14159, and it goes on for infinity. And it is an irrational number because it never repeats and it never terminates. When we are looking at circumference, so circumference is going to be what is the distance around the circle. So here, circumference there will be in blue. So sorry, I kind of got off of there a little bit. So circumference is measuring the around of the circle. To get that, we do look at one of these segments that is in the middle here. this one that goes all the way across is diameter. So diameter is going all the way across the circle. And the one that goes halfway here is the radius. For circumference, we can use either the diameter or the radius. We have two different formulas for that, and that's because the diameter is all the way across and the radius is halfway across. So it takes two radii, that's the plural of radius, it takes two of these to make one diameter. So we can use that fact and actually create two different circumference formulas. It doesn't matter which one you use. For area, we only use the radius, and the thing that typically throws people off is they forget, and if they are given the diameter, they forget to cut that in half before they put it in and substitute it for the radius. So make sure that you are good with what is the radius and what is the diameter. Volume and surface area is when we are looking at three-dimensional figures. So everything we were looking at before, circumference and area, are going to be for two-dimensional figures. But these three-dimensional figures, we can think about how much space do they take up in the world. So that would be the volume of a box. Basically, a rectangular solid is a box. So, for example, I could pull out my little timer here, and this would be considered a box, right? It has a height and a width and a length. And if I measure those and multiply them together, that will tell me how much space this occupies. And things that you're going to use that for would be, how many gallons of water does it take to fill up a pool? How much air can fit in a room? And those are going to be cubic units because we're trying to figure out how many cubes it takes to fill that space. So you can think of sugar cubes or dice. Figure out how many of those it's going to take to fill up the space that this figure occupies. So again, for a rectangular solid, so we're going to have length and width, which come from the base that we had already. And then we will have the height. So we add that third dimension. And that's where we get cubic units for volume. Now, surface area, we are covering things, and it's, you can see that there with the area. Surface area is going to be squared units. And I'm going to take this sheet away for just a second. And if you look at my craft cutting mat here, it is actually showing you what we do to figure out area. We're figuring out how many squares does it take to cover the space that I'm looking at. And with a surface area problem, it's just a little bit different because we're looking at, we want to cover all the faces of that three-dimensional figure. But squared is when we want to cover spaces. Cubic is when we want to fill things. And if I am looking at my surface area here, we're going to have a face in the front, and that face will be the same in the back, the part that you can't see. There's the top base and the bottom base that will be the same. And then we have this right face, and then we'll have a left face. So what this formula does is just say, all right, well, I'm going to take the two bases, length times width, there's two of those. Height times width, so height times width would be this right-hand shaded face. There's two of those because the opposite one is going to be the same. And then two of the length times height, so that's going to be the front face here and the back face. And that covers it. So it's like you're trying to do very, very precise wrapping for a box or a container of some sort. I do not have one of my nice boxes handy, but I do have this candle, which is a triangular prism. So it is, get a little bit better perspective on this. that. Okay, so you can see how it has the face, which is how it's named. It has a triangle base, and it has two of those. And then it has these faces, one for each edge of the base. So there's three faces around here. And that's pretty much how you figure out the surface area. We're not going to be looking at these. Like I said, these are not going to be on the exam and not going to be on the test. But just to give you an idea of what's happening with these. So we're doing some very precise wrapping. If we wanted to basically cover it with contact paper, something like that, the sticky paper you can put in your drawers, that's the same idea. And we, so we've got the two bases, and then we have those rectangular faces. With a cylinder, it's a slightly different because we're dealing with circles again. And we are going to look at, it still has a height, but then we will need to have that radius value. So we'll have that radius here. So radius and height are what you need for that. And for the volume, if you think about a stack of coins, if you figure out the area that one coin covers, then you figure out how tall the stack is. That's basically what we're doing with the volume of a cylinder. We're saying, all right, well, that circular base there has this particular area. So I'm just taking minute slices of that all the way from 0 to h. So I'm going to grab all of those, and that would be the volume that can or cylinder would take up in space. Surface area for a cylinder, same basic idea. We've got two of that base. So you can see here that this is, let's see here, pi r squared is the area of the base. And that should not have the height on it. No, that is a typo. That should not have an h there. Sorry about that. Get rid of that. Yeah. And the reason that we do not have that is because if we unfolded this, basically what we're looking at is we're going to have a rectangle that has that height of h. And then this distance along here will be the circumference of the circle. Because we are going to have two circular bases, which would then fold into place to cover the other parts of the cylinder. So we have one base here, which is the pi r squared. We have one base here, which is pi r squared. So two of those is going to be that second portion of the formula. And then this rectangle, which is the circumference. Another way that we can write circumference is 2 pi r, So you can think of this as a rectangle with 2 pi r for one side and h for the other side. And basically we just figure out what the areas are for those three shapes, and we add them together. And that takes care of surface area. So for those figures. All right, let me flip over here. The other couple things that we'll look at are, that will show up in ALEKS are a sphere. So volume of a sphere has a very special formula. Now spheres only have one measurement that we're concerned about, and that is this radius. That is the radius here. And if you have that, you can easily figure out the volume by plugging it into this formula. And same thing with surface area. We can plug it into this formula and we would get the surface area if I wanted to cover that sphere with like paint or something. To put this in a calculator, it may be easiest to do 4 divided by 3 times the 3.14, which ALEKS usually has us use for pi, so we all round to the same place. And then your radius to the third power. And then hit equals. And then that should give you the answer we're looking for. If you do any rounding of this 4 divided by 3, because it's not a terminating decimal, if you do anything where you cut that off early, it will throw your answer off. So just practice putting it in as 4 divided by 3 in your calculator. All right, guys, cut this video off.